this is more of the same, and I think subtracting is, inherently is there's some tricky parts to subtraction. So we'll look at that. X squared minus x minus 2 minus, I'm going to say get used to doing this. Put a parenthesis around what you're subtracting. You're subtracting an x plus 1, but that minus applies to everything. So I would say change the sign and distribute the negative. So you've got a negative x and a negative 1. Now you can combine your like terms. You have a negative x, another negative x according to this, but you have this x squared leading the way. X squared minus 2x is this and this, and then minus 3, which is the negative 2 and the negative 1. When you're plugging stuff in like this one here, it gets a little kooky because you're taking a g of x, which is a simple x plus 1, but you're plugging it in here and here. Because this says f of x, big picture. F of x says something squared minus that same something, and then minus 2. There's my something squared. There's my minusing that same something. And there's my minus 2. Okay? So what's the something? Well, the g of x says it's x plus 1. And this is x plus 1. Okay? You got to FOIL this. You FOIL this. X plus 1. X plus 1. We got to start there. That's an x squared. The outer and the inner is a plus 1x plus 1x. The last is a plus 1. So that gives me x squared plus 2x plus 1. But then I've got this that I've got to subtract. I've got to change the sign of. Okay? That means I'm distributing the negative, which gives me a negative x and a negative 1. But I also have this minus 2. Now if you stack them like this, you can go straight down and get everything you need right in order. There's the only one x squared, and that's an x squared. You have a 2x minus 1x. That's a plus 1x. You have a 1 minus 1 minus 2. That's a negative 2.